Welcome to LabMinutes.com and our lab video series in BGP. You can find a complete list of BGP videos on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In this video, we're going to try to increase the efficiency in BGP configuration using peer group and peer template. And although it's kind of an unrelated topic, we're going to try to convert one of our router into a VRF and try to configure BGP under the IPv4 VRF. For our network topology, we have 7 routers, R1 through R7, and each of those has BGP configured as shown in the diagram with iBGP and eBGP. And the loopback 10 through 12 are also advertised into the network. So what we're going to be doing in this lab is to convert some of these BGP sessions and replace the configuration using peer group and peer template. So the startup of our configuration is basically where we left off back in the video RS0058. So let's begin with our task number 1 with peer group. So we need to reconfigure R4 to use peer group for eBGP session to R3 and R6. Going back to our diagram, and these are the eBGP session right here as shown and labeled as peer group. So what the peer groups allows you to do, or allows the router to do, is to increase the efficiency by replicating update messages to multiple neighbors that basically share the same characteristics or route policies. And instead of having the router individually create the update messages for each of the neighbor. Okay, so to you what it means is also a reduction to configuration, as you will see, since you're going to be grouping the neighbors into a peer groups and then perform the configuration just on that peer group instead of individual neighbors. Okay, so on R4, let's do a quick show run and see what our current BGP configuration looks like. Here we have our router BGP 300 and we also have the individual neighbor command. Alright, so let's start by getting under the router BGP 300, and then first we need to create a peer group. We're going to call it AS200. Since the task doesn't really require us to have a certain name, we're just going to call it AS200 and then define that as a peer group right here. Okay, so configure peer group. Actually, let me bring up a notepad just to kind of make it easier. And then let me copy there. Alright, next we're going to configure our peer group. So we do AS200 and then you can pretty much specify any BGP commands you like, just like how you configured a neighbor. So that will basically represent the whole peer group. So for our connections from R4 to R3 and R6, we're going to have to configure a remote AS of 200. And that's basically going to replace these commands right here. And now that we have that configured, we can delete the neighbor. So it will be this command and this command for R3 and R6. And we're just going to place 2 BGP neighbors under the same peer groups. So instead we're going to copy that and then question mark just to see, and you have that option for peer group right there. Okay, we're going to place that under peer group AS200 and the same thing for router 6. So 46.6. And that's pretty much all you need. So you can see that the BGP session to R3 recovered already. So R6 should follow in a second here. While we're waiting for that, just to show you. There you go, R6 came back up. So right here, peer group and then the 2 neighbors. So from now on, as long as the configuration change that you make applies to all of these neighbors, you can apply the config or make the change at the peer group level instead of individual neighbors. Okay, although it might not seem significant right now since we just only have 2 neighbors, but imagine if you have tens or even hundreds of BGP neighbors. All you need to do is just make that one command addition as part of the peer group and you're good to go instead of making an individual neighbor configuration change. Okay, so that's pretty much what the peer group is all about, and that completes our task number 1. Okay, so next is our task number 2 with peer template. We need to configure our 1, 2, and 5 to use peer template for all the iBGP sessions. So right here, 1, 2, and 5. Because since we're going to have the pretty much consistent configuration amongst the iBGP neighbor, this is the good candidate to use a peer template. So just to talk about difference between the peer template and peer group, as you can see, right here with peer group, the peer group, it kind of ties both the peer config and the outbound route policies together. And that makes the configuration kind of inflexible a little bit because that requires all the neighbors to have identical peer config as well as the routing policy. So as soon as the neighbor requires a unique configuration, you're going to have to break away from the peer group. So that's why it makes it less flexible. But with the peer template kind of breaks those apart into two parts, which is the peer configuration and the policies themselves. So it's kind of make it more modular in the sense, and at the same time allows you to build like a hierarchy of configs since you can do inheritance and all that. So for a greater flexibility as far as configuration, then the peer template is definitely a way to go. But if you just want a quick and dirty kind of keep your configuration short without having to go through a different set of template, then definitely use the peer group. All right, so now we need to reconfigure R1. And let me do a show router BGP. Let me just copy that out so I have a copy of that. And then let's go under router BGP 100. As you can see, for each of these neighbors, we keep repeating the update source loopback 0 as well as the next hop self, and obviously the remote AS100 as well. Okay, so first we're going to have to create a template. If you do question mark, then there are two types of template. One is peer policies and the other one is peer session. So we're going to start off with the peer session, which is the configuration related to the session itself. And they have to give it a name. So we're going to call it AS100. And if you do question mark, you can see the related configuration of commands for the peer session is things like eBGP MADI hops, password, remote AS, timer, update source, or version. So these are something that is not related to the policy, but instead more of a configuration for the peer. Okay, so the command that we need is remote AS100 and the update source, loopback 0. Okay, then we're going to create another template for the peer policy. And you can also give it a name. It can be the exact same name, so we're going to use AS100. And if you do the question mark, just to get a feel of what kind of the commands are available under the peer policy, you see things like allow AS in, filter list, next hop cell, which is what we're about to configure, prefix list, route map, send label. So things that's related to a routing policy, whether it's inbound or outbound, you can configure them under the peer policy. So for us, all we need for now is the next hop self. Enter. Then we're going to go back and kind of remove some of our configuration, and that is, let me see, I have a notepad right here. I'm going to have to remove anything that's related to all the by BGP. So right here, put a no in front of all these, and then copy. Okay, make sure that all of those are removed. Yep, all those are gone. Next, we're going to configure the neighbors to inherit the policy or the template. So neighbor, start off with router 2, 02. You can see inherit. And I forgot to mention right here, under the actual template itself, there's also an option to inherit. So you can do or build a hierarchy of template that inherits a policy from another template. But for our neighbor configuration, that has to inherit first with the peer session, and we call it AS100, and then that also need to inherit the peer policy AS100. Same thing for the 0.5, which is R5, and for the peer session and for the peer policy as well. Okay, let's take another look at what we have right there. So although it's a little bit more command for peer template, but you can see it's much more flexible. So you can pretty much create a separate template for whether it's for sessions or policies. You could have them share among different neighbors. But the ideas are same. Once the template has been applied to the neighbors, you don't have to pretty much touch the neighbor command. Again, you just have to make modification to the template unless the neighbor or the particular neighbor has a unique requirement that needs its own neighbor configuration, then you can just override that using neighbor command, just like peer group. Okay, so it looks like router 5 came back up already. I don't think I saw the router 2. There you go. I think it came up earlier. So The session has recovered with the peer template. Now let's look at some show command before we move on. So we can do show IP BGP, and then there's a option for template, and you can use, or you can view either peer session or peer policy. Okay, so for peer session we have remote AS100 update source loopback 0. This is for AS100 peer session, and then for peer policy we have the next hop self. So now we're going to repeat that with router 2. So let me go back. I'm just going to go ahead and do a copy and paste now, since it's going to be pretty much identical. Okay, we're just going to work off a notepad. So right here, peer policy, peer session, instead of 2, it's going to be 1 and 5. And then we copy this neighbor command as well. Obviously, if you can copy and paste, there's no reason for you to type it out again and again. Okay, 1, 1, and 5. So let's start off with this. Let's do one section at a time, so we can verify along the way. So this applies successfully. Let's do that twice just to make sure. Before we go ahead and apply the template, make sure all those the previous configuration has been removed. And let's go ahead and copy that and paste. Okay, while that's still coming up, let me modify this for router 5. Everything is exactly the same. Then there will be 2 and 2. Okay, so it looks like that recovered 2. Then we go to router 5. Just remove it twice, show run. Okay, so all the neighbor commands are now gone, so I can go ahead and copy and paste that. Give it a couple seconds. Okay, the router 1 session is up, and then also router 2. To show BGP summary, everything is back to normal. Let's take a look at the route real quick so we can see all the 1, 2, 3, 4, 5, 6, and 7. Okay, so now we're pretty much back where we were, but now with the peer group and peer template commands configured. So that completes our task number 2. So moving on to task number 3 with IPv4 VRF. So hopefully you guys have some idea what the VRF is. So basically VRF allows the router to be virtualized by having a separate routing tables, and usually that's used for a secure reason to keep the traffic separated at the network routing level. But from time to time you can use it also as the advanced routing functions in a more complex design. We will deal with the VRF a lot more when it comes to MPLS VPN. That's since it's more like, or a lot of the traffic separation is going to be required since you're using a shared network to provide services to multiple users, and you want to make sure the traffic between the users are not mixed together. But for us here, since we're not dealing with MPLS VPN, to be technically correct, we're just dealing with VRF Lite. So you might have heard the term of VRF Lite. And this is just when you create a VRF in your network without dealing with MPLS VPN or PBGP with multi-protocol BGP. Okay, so what we need to do is to create a IPv4 VRF named BGP with a RD or route distinguisher of 65123, 65123 on R7. And then we're going to have to place all the interfaces under that VRF so it becomes a member of the VRF, and then reconfigure a BGP session to R2 under that same VRF. All right, so we need to be on R7. First we need to create our VRF, and the command for that is IPVRF, followed by the name of the VRF. And so we need the name of VRF BGP. And then question mark. There's not so much that we can do under the IPVRF, but what we need here is the RD for route distinguisher. So RD is 65123. Actually, let me do a question mark. You can see the format is ASN and some number, or the IP address and some number. Okay, what we need is 65123, 65123. Next, we're going to have to reconfigure our interface and place them under the VRF. So let me do a show IP VRF so you can see. Currently, we have one VRF with no interface. And let's see what interface we have to deal with. So let's start from the top with the fast Ethernet 00. The command to place the interface under the VRF is IPVRF forwarding. And this is specific to a router running iOS a regular iOS, you might encounter different variants of that, which is just like a VRF forwarding on the, for example, ASR router that runs the iOS XE. Here all we need is IP VRF forwarding and the name of the VRF, which is BGP. I can see as soon as you press enter, it said the IP address has been removed due to the enablement of the VRF. Okay, so if you take another look at the interface, the IP address has been removed. So every time you place an interface under a VRF, you have to reconfigure the IP address. So that would be 1627.7. Okay, same thing with loopback 0. So let me do this just to save the configuration. Okay, so let me copy the loopback 0, all of these, and then do a IP VRF forwarding BGP on each of them. There you go. Copy that, paste, and now if we do show IP VRF, you can see that all of the interfaces should be listed under that VRF. So just to do a sanity check, we should have 5 interfaces, and we do have 5 interfaces. Okay. Now let's see what we have as far as the BGP configuration. Okay, so let me copy that out because we're going to have to reconfigure that. And the way to configure your BGP is to create an address family and place the relevant commands in the address family. So what we're going to have to do first is to remove some of the command from by default, these will be a regular BGP or IPv4 BGP. So we're going to have to remove anything that's routing related or neighbor related. So let's do no of that. And let me remove this line as well. And then we have to place them under the address family. And so you can either do IPv4, or if you configure the IPv6 BGP, you pretty much follow the same procedures with the address family command, and then you have the option to do multicast, unicast, or VRF. Okay, first we're going to do VRF, and then the name of the VRF. Okay, then we can just put the neighbor command back in. Let's see if we can find the neighbor command right here, as well as the redistribute connected. Okay, and the last thing you always wants to make sure you don't forget to do is to activate the neighbor. Alright, then you give it a few seconds. There you can see that the BGP neighbor came up already in the VRF of BGP. And then just to do a test ping to R2 across the VLAN 27, when you ping, make sure you specify, once you put something under the VRF, from then on you have to make sure you specify the VRF along with the pretty much all the commands that you issue into the router. So here we're doing ping, so I need ping VRF BGP 172.16.27.2. So there you can ping a router R2. And then to check the BGP peer, instead of, if you do go ahead and do IP BGP summary, you can see that we are seeing nothing because we no longer have any BGP under the IPv4 BGP. So what we have to do to see the neighbor under the VRF, you're going to have to specify VPNv4, and then the name of the VRF, and then all the commands after that will be the same as any other IPGP command. Okay, so if you want to do summary, then you can see that we have a router R2 as our neighbor with the 19 received routes. Same thing, we're going to do a show IP VRF, or show IP BGP, VPNv4 VRF BGP neighbor. You can see that you can also look at the neighbor information as well. Okay, just to make sure that R2 is still receiving routes from router R7. And you can see that it's still advertising routes from R7 to R2. And R2 has complete no ideas that R7 is running a BGP under the VRF. Okay, so if you do and show IP route without specifying VRF, that means you just look at the global routing table. But obviously, what we want to look at is the VRF routing table. So just specify the VRF option. You can see that all the routes being learned through the BGP, VRF BGP, it's been placed under the VRF BGP routing table. Okay, let's try to ping all the way out to, And obviously, yeah, again, don't forget to specify VRF BGP all the way to 8888, which is on the R6. The back 10, you can see that's pingable. Okay, so that's complete our task number 3. Alright, so although we haven't really done a lot of configuration of the peer group and peer template, since we don't have too much of the configuration in the network right now, but from now on we're going to be using this particular setup with peer group and peer template in place. So for our future video, whether it's a route filter or past selections, we're going to have all those configuration done under the peer group and peer template, so you guys will be able to see a lot more config using those features. Alright, so that wraps up our video on BGP peer group, peer template, and IPv4 VRF. You can visit our website to view an extensive list of our lab videos and sign up to get access to additional lab contents. Thank you for watching LabMinutes.com, and I'll see you guys in the next video.